say we're given, or we have the following polynomial. 50, that's just a number, plus 2.2x, so that's a decimal coefficient, minus 3x squared, plus 4x to the fourth. Okay, so this is an example of a polynomial because we're adding terms which consist of power functions. Okay, so these coefficients, let's identify what our coefficients exactly are. Okay, we're going to be defining a lot of terms because polynomials come with terms. So coefficients are basically your numbers in front of your variables. Okay, so the coefficients in our case would be 50, another coefficient is 2.2. Another coefficient, you have to be careful because this is actually adding a negative 3, x squared, right? So this is going to be a negative 3. We also have, where's our x to the third term? It's kind of hidden, right? Because we actually have a 0 in front of it. So 0, you can swap these two. It doesn't really matter because addition is commutative, which means you can move stuff around. Anyways, so our 0 is the coefficient in front of x to the third. So we could write that in there. It's a little bit trivial, but I just want to point that out, that the coefficient of x to the third is 0. Okay? And then our coefficient of x to the fourth is a 4. Okay? So now I'm going to define a few more terms, no pun intended, but anyways, a few more terms or like definitions that we need to know. So the first is coincidentally called a term of a polynomial. I'll just abbreviate here. So term of a polynomial is basically equal to anything separated, so anything separated by a plus or minus sign. Anything separated by a plus sign, actually. Separated by a plus sign. Okay? So in our case, what we have is, well, we have this 50 separated by a plus sign, right? From 2.2x separated by a plus sign, from negative 3x squared separated by a plus sign, from 4x to the fourth. And then we also have this kind of like 0x to the third, but that's just kind of on the side. So our terms would be 50. We kind of just get rid of the plus sign. We ignore that. Another term is 2.2x. Another term is going to be negative 3x squared. Another term is going to be 4x to the fourth. And if you really feel like it, you could list 0x to the third as a term as well. Okay, and that's a 3 there. Okay, so another thing that we need to know is what is a degree of a polynomial. So degree is basically just the highest occurring power in your polynomial. So highest occurring power in your polynomial that doesn't have a coefficient. Occurring means like it doesn't have a coefficient of 0, because technically we could add on, oh, we also have 0x to the fifth, 0x to the seventh, 0x to all this stuff that we don't see. But occurring means it doesn't have a coefficient of 0. So you can actually see it in your normal polynomial, right? So the highest occurring power in ours is going to be a 4, right? And so the degree is 4. So the degree of ours is 4. Degree of 4. Okay, so let's continue this on the next slide. So we have f of x is equal to 50. Let me just write this out one more time so we can use it for our second set of terms here. Okay, 3x squared and plus 4x to the fourth. So our next term is going to be called the leading term. Okay, leading term. This is basically equal to the term, so the thing separated by a plus sign, right? So term with the highest degree in it, with the highest degree. And in ours, we already determined that the highest degree, or the highest power, highest occurring power was a 4. So we're just going to take that whole term and call that the leading term. So 4x to the fourth is our leading term. And the final thing is going to be leading coefficient. Okay, and as you might assume, this is basically just the coefficient of whatever your leading term is. So yeah, that's kind of self-explanatory. Anyways, I'll just abbreviate. So coefficient of your leading term. And in our case, coefficient just means like whenever you think coefficient, you should think, okay, constant or number in front of something. Okay, so coefficient of leading term. So that just means we're going to pull out this guy in front, and that just happens to be a 4 as well. So that's going to be our leading coefficient. Okay. So one last thing, and this isn't really a term or anything, but just something to note is we often arrange our polynomials in descending order. Descending order. Well, I guess that's kind of a term on its own. Descending order just means like in terms of highest to lowest degrees. or powers, you could say, okay? So what does that mean? In our case, that would mean we're going to write our leading term first. So that means 4x to the fourth, because that has the highest power. The next highest power would technically be like our 0x to the third, but that's not super important. So we're just going to skip over to the next one, our next highest power, which is 3x squared, right, because we have a power of 2. Our next one would be the x one, so 2.2x, and then plus 50. And we oftentimes do this because of the following fact. That the long run behavior of a polynomial matches that, or it basically dictates. So it matches the long run behavior of your leading term, of the leading term. Okay, so this is super important fact. That's why I'm taking up a whole slide to just write it all out. Okay, so basically on the one that we had here, f of x is equal to our 4x to the fourth minus 3x squared plus 2.2x plus 50. If we were to look at all these and be like, okay, so I know what this one looks like on its own, I know what this one looks like on its own as a graph, I know what this one looks like, and I know what this one looks like, so what does this whole thing look like? So for the general overview of what this graph looks like in the long run, you would look at your leading term, okay, and you say, okay, what does this do? And then that basically dictates, because it has the highest power, it has it's kind of called power for a reason, right? Because power means it has that much strength behind it, kind of thing, in the long run. So this one kind of dominates as x goes to positive and negative infinity, okay? So this one would look like, since this is an even power and it's positive in front, it would look something like this on both sides in the long run, okay? Alrighty, so we've discussed some long run behavior, so now let's go over short run or short term behavior, okay? So what does that even mean? So this involves discussing vertical and horizontal intercepts, okay? Vertical and horizontal intercepts. And intercepts just means kind of like in football, right? So where something crosses something else, right? So in our case, that would be where our graph crosses the vertical axis and the horizontal axes, respectively. Okay? So again, just a refresher, so vertical intercept is where, like I just said, where our graph crosses the y-axis or the vertical axis, and that would be when our input is equal to 0. Okay, so when input, which is usually denoted as an x, when input is equal to 0, so that means the point or the coordinates would be determined 0 and then f of 0, whatever that happens to be. Okay, and there's only one of these for any function because you can only have one y value for every x, right? And then for horizontal intercept, so this is when our f of x is equal to 0, okay? So these are also called, just for kind of self-explanatory reasons, these are also called zeros of a function, okay? That's just because the function equals 0 at those points, okay? So because this happens here, so then we could have a comma 0, b comma 0, etc., etc. So you could have more than one horizontal intercept. That's fine. Your graph can cross the horizontal axis more than once. So you can have actually 0. You can have 0, 1 or more horizontal intercepts for a graph, for a function, okay? And we'll go over that in the future. Okay, for this example, we're going to look at this polynomial function. So f of x is equal to x minus 2 times x plus 1 times x minus 4, written in factored form for our convenience. Determine the vertical and horizontal intercepts. So let's start with vertical, because that was listed first. So vertical intercepts. So that is when our x is equal to 0. Okay, so let's just plug that in. So we get f of 0 is equal to 0 minus 2 times 0 plus 1 times 0 minus 4. Okay, so on the inside we just have a 1, so that kind of is just there. So we have minus 2 or negative 2, and then times negative 4, so this equals a positive 8. So our vertical intercept is going to be the point 0, comma, positive 8. Okay? And now let's move on to our horizontal intercept, or intercepts, or none. All we have to do is set our function equal to 0. Okay? So 0 is equal to x minus 2, x plus 1, and x minus 4. So what x values could possibly make this equality true? So we could have, well, x is equal to 2. That's one of them. If x were equal to 2, this thing would be 0, and 0 times anything else just is 0, right? So that could make it work. How about this one? We get x is equal to negative 1, right? That could work, because then that would make this guy be 0, which would make the whole right side be 0. Or the last one is x could equal a positive 4, okay? And that would do the same thing respectively. So our horizontal intercepts would be the points 2, 0, negative 1, 0, that's a 1 here, and positive 4, 0. Okay? Alrighty, that concludes our concepts video on powers and polynomial functions. I hope that helps, and I'll talk to you in the practice problems video if you watch.